Looks like we've got a good contingent here, more than 50 people. So let's go ahead and just start off with the introductions. So welcome everyone to the Washington Capital Area ICEAA virtual luncheon presentation today. And today our topic is leveling up your cost analysis with data science tools. We have three speakers today: Sarah Green, Captain Dakotah Hogan, and Jacob Scher. And let me introduce our speakers. So Sarah Green is an ops research analyst at the Air Force Cost Analysis Agency, AFCAA. She's currently leading AFCAA's efforts to integrate data science tools and methods with more traditional cost estimating processes and techniques. She has worked in the cost estimating field for over 15 years, supporting a variety of agencies, including the Air Force, Space Force, Navy, and NATO. She has a master's in systems engineering and a bachelor's in mathematics. Captain Dakotah Hogan is an active duty Air Force officer assigned to the AFCAA, and his professional experience includes development and production cost estimating and analysis on the KC-46, F-35, and the F-22 programs. Captain Hogan has a master's in cost analysis and a data analytics certificate from the Air Force Institute of Technology, as well as a bachelor's in science and economics from the U.S. Air Force Academy. And our third speaker, Jacob Scher, is an ops research analyst at the AFCAA, where he builds lifecycle cost estimates for UAV programs. And while in government, he has developed Python models to streamline cost estimates and data analysis processes. Jacob has a bachelor's degree from Tufts University. So I'd like to welcome our speakers and start with our topic here: leveling up your cost analysis with data science tools.
Thank you, George, for the introduction. I appreciate it. And hopefully everyone can hear me. Let me get the slides going here. All right, so today's subject, we are very energized about what we're going to talk to you about today. There's a lot to go through, and there's three of us that are going to try to squeeze everything we can into the luncheon. So if you do have a question, feel free to post it in the chat, and we will try to circle back to those at the end of the presentation. First of all, I wanted just to kind of go through and set the scene a little bit. I have some bad news and some good news. So the bad news, which I think some of you would, and maybe not everyone agrees, but this is our personal, assessment, is that the cost community is way behind the curve from a data science perspective. If you look at the state-of-the-art tools out there today, not even just in that, you can look at a lot of the technologies. You make a fraudulent charge, you get an immediate phone call. There is real-time analysis happening out there, and some very, very powerful data tools and analysis available today. Generally, what we're noticing is that our processes are outdated. If you think about, I've been in this field for about 15 years, and honestly, when I look at the analysis and the way we do it today, I see not a ton of differences from the way that we were doing it 15 years ago. So, the processes, that's one of the primary things, and then also the tool sets that we're using. So I know we struggle in organizations, especially at a higher classification level, but even at the unclass level, to really have tool sets that enable us to do what we need to do in a timely way and an efficient way. And then we also, here we're doing a PowerPoint to start out with, but we're gonna switch to a demo. We've lots of times we're kind of used to, and our leadership's used to, really static PowerPoint charts. And we're really starting to move more towards like interactive demonstrations. And I don't know if you've seen that trend as well in your organizations. So I would say that's the bad news. The great news is that, number one, we have more data than we've ever had before. Now, as cost estimators, we're always wanting more and more data, but especially for the DoD, we've done a complete overhaul of the flex files. That's a huge difference to where we were, 5 years ago with the 1921s. We have now cloud-based platforms like Advana. Advana is pulling in over 750 data sources. That number is actually really old. I'm guessing they're over 1,000 now. And then you have also sites, that cloud-based platforms that are ingesting data that, before, especially a long time ago, we're talking about, paper or PDF submissions. So we've come a really long way. The other good news I would say is that as a community, generally speaking, we have a lot of the building blocks that are necessary to succeed in the field of data science. We've got a lot of really technical people, a lot of mathematicians, engineers, those types. And there actually is a lot of overlap. So if you look at what we do as cost estimators, as far as taking data, making future predictions, and then you look at some of the description of like a data scientist, there's a ton of overlap. And for me, there's been a lot of discussion, especially if any of you were at the ICEAA. There was a whole panel about what data science is and how that integrates to what we do as cost estimators. And I've been thinking about this a lot, and I really think it's not even necessarily in the resulting products as much as it's how we get there, right? And so I really think, like I said, the other good news story is that we're a lot closer than you might think. So I wanted to kind of show you and walk through today some of the tools that that are available right now today. This is not some futuristic sort of talk, and some of these tools have been around for a lot of years as well. So we're just now starting to kind of delve into that. So again, while we have that good news, we still have kind of the bad news side as well, right? Which is we're really not there as a cost estimating community. We're still really, our processes a lot of times are to pull data down in Excel, right? That's a single point in time. That's a static time. If we then are doing things in Excel, right? We have, let's say we have a series of 10 steps we need to go through to turn columns into rows, or to label certain fields, maybe turn some fields into dummy variables, steps like that. We're just going to have to repeat ourselves all over again when we get new data. So how do we bridge that gap? How do we start to automate some of our processes? How do we start to utilize some of these tools? So that's really what we want to talk about today. I'm not here to tell you all the answers. We certainly don't have them. AFCAA, we're on this journey. We're learning as we go. But we just want to share what we found out so far, and we have some, like I said, some pretty exciting results to share as well. So first of all, what is the vault? So I'm going to talk about the vault throughout the presentation, and we are going to, the three of us are all going to be showing you demonstrations in the vault. So what is it? It's a cloud-based platform, and the vault stands for Visible, Understandable, Linked, and Trusted. It is run by the Chief Data Office of the Air Force. However, even though it is an Air Force-based cloud platform, it is available to anyone that has a CAT card that's on a government network. So what we found is the real value of the vault, and something that you absolutely have to do if you have proprietary data, is the ability to establish what they call a tenant space, which is really just kind of a walled off, let's say it's S3. If you guys are familiar with some of the cloud storage, it's Amazon GovCloud is what they leverage. But it's basically just a file structure that's protected, that's walled off, so that we control within AFCAA if we put any data, proprietary or not, in our tenant space, we have complete control over who's in that tenant space. And for us, it's just government, civilian military employees. So there's no contractors in that space. It's just the AFCAA employees. So that helps us to be able to really kind of, freely model and things like that within that space. And what it really does too, the other real value of it is that and probably the most valuable thing is it provides analysts with very powerful software tools that help us to centralize and automate. So if any of you have ever tried to, for example, use RStudio get it downloaded, try to get packages imported. I don't know about you, we've run into a ton of issues with that, right? You have version issues. If you try to then share that code with someone else, they've got different versions of packages, especially if you're on the high side and you're trying to do anything in R, Python, it can be a complete nightmare. So this platform, it is on CIPR. Not all the tools that I'm going to show you today are on CIPR yet, but they are all on the roadmap to get there. And even JWICS, a lot of the tools are on the roadmap for JWICS as well. But the CIPR Vault instance does exist. They're just in the process of pulling all those tools. So everything you're going to see here, obviously we're on the unclass side here, but that's also, a huge benefit of the Vault. So the reason we chose the Vault, you might hear of other platforms. You might hear of Envision. You might have heard of Advana. Those are all cloud-based platforms, and they work really together. A lot of times they work together really well. They specialize in many different things. So I'm not going to go into all the platforms right now, but there are definitely different reasons why you would have one platform versus the other. There's advantages of having large amounts of data pumped out to, for instance of data, right? And ingesting tons of data and then pumping out mass, like charts and graphs to a much, large community versus the vault, which really is focused on deploying tools, specialized tools for analysts. So, Vault has been around since 2019. So it's not a new platform, certainly. It's proven out, it's stable and all that. And again, it's the Air Force Ops Research platform of choice as well. Like I said, it's a lot more catering towards the more advanced analysis versus just some of the visualizations. So I could talk a lot more about that, but we've got a lot to get through. So let's move on to the value of Vault. So first of all, I think, so a lot of you might be thinking, hey, I have my tools, I'm doing just fine in Excel, and that's fine for today. I just encourage you to keep an open mind as we discuss, because even though you might be fine today, the reality of the situation is that you're just going to be getting more and more data down the line, especially if you're working and supporting the DoD. We are now dealing in the world of flex files, right? So once you start to accumulate, large amounts of flex files, that turns into a lot of data, and you're going to break Excel pretty quickly. So we're just started on this journey. This is a chart from the Capt, actually even several months old, where we're expecting a bow wave of data just in the next couple of years. So, so really what we're doing with the Vault, let me just kind of walk you through. This is just a very high level kind of overview. Hopefully it gives you a little bit of a picture of what's going on. The Vault can ingest data from all different sources. So it can be anything from uploading an Excel file from your desktop. It also has the ability to connect and live pipeline data in, right? So if we have, the only restrictions is that, you have to have an API, you obviously have to have access to that API. You can pipeline data, for example, from Advana to Vault, and vice versa, right? So a lot of those connections are already set up. In our case, we don't have those APIs. So, we can imagine maybe some future world where some of our data sources could be pipelined in. That's not happening today. Right now, we're taking, bulk downloads, or we're working with some of those functions with some of the websites. And so we're taking that data, and what we're trying to do is all of the steps that you see on this page, which if you think about it, I mean, these are just the basic cost estimating steps, right? You've got your raw data. You go through some series of data cleanings, transformations. A lot of times you do an exploratory analysis where you're looking at the data, you're visualizing the data, and then eventually you're doing the prediction and modeling. So what we're trying to do is we're trying to gain efficiencies, and also not only just gain efficiencies, but also have that sort of centralization, right? So instead of having instead of having sort of instances of the data scattered on shared drives or desktop versions, we're trying to really centralize all that data and then go through, like I said, a common set of data cleaning and transformation. So you will see these are not all the tools available in the Vault. These are the primary ones that we're using. I would say we're using we're actually if we're just building visualizations, it's really Tableau that we're using the most. If we are doing modeling, we're pretty heavily using Dataiku at this point. So we're going to talk about that. We're going to talk about both of those, but mostly we're going to talk about Dataiku because that's the modeling portion, which at the end of the day is our bread and butter, of course. I'm not going to walk through all this. Essentially we've realized a ton of benefits, right? I've already talked about some of the manual steps, also traceability. So right now we're very dependent on the analysts and their initiative and them taking the time themselves to document every single step of the way. The really fantastic thing about this process is that as you go through, if you have these automated steps, the process is not only documented, but it's right there where you can trace every single step. You even have something like, for example, if I'm in a model from the very beginning of the model to the very end result, it is actually tracking every step. I can revert back to an earlier version if I'd like to, things like that. So very, very powerful, kind of the time capsule capability, if you will, as well as the traceability. So lots of other changes here, or lots of other benefits here. Of course, I have to mention performance and desktop compute. Most of you, if you're working with data sets that are 100 data points, you're not going to even run into these issues. But like I said, eventually down the line, you will eventually be working with a data set large enough that you are going to have issues with performance. So I'm not going to run through all these, but essentially what we're trying to do, I've said this quite a few times, centralization, automation. There are lots of things. Right now, we're sort of done with the proof of concept, and we're really moving on. We're just really now starting to try to move on to specialized use cases, and trying to focus in on the most compelling use cases throughout AFCAA for all the different commodities, and really start to build those models. So again, proof of concept is kind of behind us. Having said that, we are working on customized cost applications. And this is where we see a lot of potential to collaborate with the greater cost community, because the problems that we have in AFCAA are not, they're not unique, right? So wanting to do something, wanting to customize functionality, for example, for learning curves, for escalation, for Monte Carlo analysis, those are things that the entire community is interested in. So we see a lot of potential to be able to leverage each other's work and to collaborate and share throughout the community. Okay, so with that, I am going to jump into the live demo. I am going to also drop my camera just because I don't want there to be any issues with delay or feed. So, so as I get that going, let's see here. So the first thing I'm going to pull up is going to be just kind of the Vault homepage. So, it's really all it is like I said, it's an accumulation of tool sets that are at your fingertips. So these are the tool sets that I have, like I said, specifically requested access to. I'm going to run through. I'm going to spend very little time on some dashboarding. I do want to show you, just in case some people might not have seen these. One of the exercises we're going through is trying to consolidate different data sources and pull them all together, give analysts hands-on access to that data, and at the same time start to build some visualizations for them, right? But by no means is this all that's possible. So what we're doing is, like, for example, this is an example of, and this is all this is the only chart that has real data is this chart. So for example, this one, we're pulling in information from the SAR, which has detailed information on the milestones, both at the program level, the space level, and the ground level. So all this information is from the SAR, but we're also pulling in data from CAPE, from CADE, the contracts data, budget data from Advana, the EVM data from EVMCR, and some technical data as well. So what you're going to see is again just demo data, but you can kind of get an idea, right? I think everyone at this point has seen a demo of some interactive charts and visuals. So it's not necessarily just that I'm trying to show you. It's more of the concept of pulling all this data together, having it in one spot, and kind of consolidating that for the greater audience. So I'm sort of keeping an eye on the chat. So I'd like to say something if it's relevant. Yeah, you can definitely load your own data. So that's the beauty of, so like what platforms like Advana and some other platforms, like I said, not to say that, I'm not going to say whatever platform can and can't do, but their main paradigm is pushing out data to a larger audience. Vault is really more of a bring your own data platform. So Vault is very much, hey, uploading your own data, things like that. Now, I will say if it's proprietary data, you really have to have a tenant space uploaded. So if you upload something to the Vault without a tenant space, everyone in the Vault can see it. So that is an absolute, definitely do not do that. But if you do have it, once you have a tenant space set up, you have your own S3 bucket, which is access to basically your own storage, when you have complete control over who can see that data and who can't. So again, I'm just flipping through really quickly. The point of this briefing is not to go over all this. It's just to kind of show you proof of concept, what we're doing, pulling in different data from different sources. What we'd really like to focus on now and for the rest of the session is some modeling. And we're going to show you Data IQ. Now, I'm not saying this is the only tool that does this. This is the only tool that we have access to that does this at this current point in time. So that's the one I'm going to show, not endorsing any one tool over the other. But I will say that, like I said, this has been deployed on the Vault. And it is a, what Dataiku is it's a low code, no code tool that allows you access to do pretty much anything that you'd like to do in the data science realm. You can, it's got tons of out of the box functionality. So I'm going to show you, we're going to show you some of that. I'm going to give an overview of the model, some of the prediction capabilities, and then Jacob's going to talk about some of the customizations that we're doing, and then Captain Hogan's going to talk in more detail about the preparation steps. So I'm going to hurry it along here, but I just to zoom out. So for example, you know, within Dataiku, it works on a project to project basis. So this is a project that I built, and it all starts with a data set. When you're in a data set, you've got all kinds of options and I'm going to say out of the box, right? Out of the box steps, which are kind of drag and drop, where you can, they call it recipes. So think in terms of moving left to right. So if everything starts with the data set, then you can go through a set of preparation steps. You can do all your data cleaning, data transformation, a lot of very, very sophisticated things that a lot of times you would need to write Python or R code for. And again, I'm not going to go into the prepare now. We'll revisit that later. But the idea here is that if you think in terms of a cost estimate, what we're doing here is really, it's really not that different. It's just, it just looks a little different visually. So we're starting with raw data. We are then doing our preparations, right? Then we're running our prediction models. So these are some prediction models, for example, on payload mass. And then we're feeding some inputs into that model, right? So this is the same, think of it as the same thing as developing a CER, and then building out, you know, in the space world, that would be for like a payload and a bus, for example, and then feeding inputs into that model, right? So you're using your raw data, you're feeding inputs into that model. This entire process then predicts mass, right? So that's the first kind of section. And again, I mean, this is all customizable. So you build your own steps, you make your own predictions. In this case, I'm just kind of an example of how then that mass can feed your cost estimate. So in this case, those global inputs then continue to feed my cost estimate, which in this case, you know, is a prediction of like T1 in non-recurring costs, right? So again, you know, you think about it in terms of like, instead of different tabs in Excel, you might have, you know, these different data sets. So all the blue boxes are data sets, all the yellow steps are preparation steps, and all the green are predictions. So again, I'm not going to go into too much detail. I just want to show you a couple of things here, mainly just when you start, when you click into the data. What I really love about this tool is everything in one spot. So it's all your data, for one thing. And then it is, like I said, your preparation, which Captain Hogan's going to talk a lot more about that. You've got tons of options as far as, you know, the processors that you want to employ. And what I want to talk about right now, and then I'll hand it over to Jacob, is the prediction capability. So what I really, really appreciate is if you ever have sat through a presentation about machine learning, it might seem like, hey, you know, this is an abstract concept to you. It's maybe difficult to kind of to put your arms around. What I really like about Dataiku is it's a fantastic stepping stone into the data science world without having to touch a line of code. So for example, designing a machine learning model, normally, again, this would involve lots of code. It would involve, you know, either way, if you're doing this and you're really deploying this, you've got to really do your research on some of these algorithms and do your research on the machine learning part. But I really like that you can actually focus on that part and not have to just go become a coder for, you know, spend a year learning Python. So what it does is it allows you to design your experiment. So for example, if I'm going to predict, in this case, total payload mass, right? I have all kinds of options here, doing, you know, k-fold cross tests, for example, feature handling. So instead of having to create a bunch of zeros and ones for dummy variables, I can tell it exactly how I want it to treat categorical variables. If I have a numerical variable as well, I can, you know, it lets me impute data. It lets me impute it, you know, however I like to, things like that. And then for algorithms, you've got a lot of different choices. It does things like tree-based models. It also does OLS. It's going to run through all these, and it's going to tell you what the best results are based on what your target function, you know, your target is. So minimizing MSE, minimizing R squared, whatever you'd like to do. And then the results of all this, so once it gives you the results, it also has, oh, sorry, one more thing I wanted to mention too. If there's not something out of the box, like I said, it's highly customizable. So in this case, for example, you can add a custom model as well as everything that comes out of the box. So if there's anything on here that you're trying to run that you don't see, you can run that model, and then you can also take advantage of all of kind of the out of the box features. So for example, once you run your model, there's lots of different ways. I mean, just classically, decision tree type models, machine learning is classically a lot less interpretable than something like OLS where you have an explicit equation. But what I appreciate about this is that it actually walks through, like, for example, here, you can actually see all the trees. If you have a decision tree model, you can actually see all the different trees that are there. You can also walk through different scenarios as far as, and again, this is a demo, but you can kind of get the idea. So I have no idea what the number is going to say here, but given the number of transponders, given the band, given the satellite class, given commercial and military, you can get kind of a real-time feel for what the number is going to be. And then of course, scatter plots, error distributions, all those types of things are available as well. So having said that, I already took a little bit more time than I wanted to. So I'm gonna pass the screen share over to Jacob, who's going to talk a little bit more about some of the customization features that are available.
Thank you, Sarah. So as Sarah mentioned, we found that Dataiku has been a very powerful tool for what we've been doing, but it hasn't always had the tools specifically we need for cost analysis. While it might, be possible in a few, more steps than we would like, we have been able also to take advantage of the customizability features available within Dataiku. So a couple areas that we saw in particular that were kind of unique to the cost analysis world were learning curves, inflation escalation, that we felt like we would be helpful tools to have in our toolbox, but didn't come straight out of the Dataiku in their prepare steps. So we were able to create these, instead of the yellow, which were the prepare steps, these plugins, which are these purplish red steps. And all they are is one person has to go and take, unfortunately, you do need a programming background, but just a little bit, and it is easy to integrate any Python, R, SQL, whatever into the Dataiku platform. So once one person goes back and does it, then it's deployable to everybody who is in the vault. So in this case, this plugin here is going to develop the learning curve slope for an airframe and missiles. And in here, we can see that we have a nice user interface that's easily designed by Dataiku itself. The user actually doesn't have to do it. Or it just sets, what the input should be, and then Dataiku, generates this nice looking page with a drop down where a user can pick various options, and that will then derive a learning curve. One thing that we have also really liked about it is that this is therefore very traceable. So ultimately, when we go to score our model, so when we look at what our T1 and learning are going to be for a future program to actually model it, this way we can see, okay, well, I'm using my learning curve from this airframe program and this missile program, and they're not just usually when we would do it in Excel, we would just fat finger it in from a regression that we either ran in CoStat or somewhere else in our Excel spreadsheet, but it's not traceable like it is here. And the other thing that we've also found is that sometimes when you do run this regression basically in the plugin instead of in an Excel, well, it would happen in any event, but sometimes your T1, your learning, or rate don't show up exactly the way you want them to. So we've added the ability here, or Dataiku comes with the ability to push to editable. So we can basically go in and now edit our learning and rate. If, for example, it says our learning curve is 110%, which generally doesn't make sense for a program, you can go in and edit it. And when you do that, we can see these cells here highlighted in blue are the ones that I have changed after the fact. So this is another instance where we have that traceability, so we can know, okay, I know an analyst came in and made an edit. And an analyst can also leave comment features too, I believe, to each step saying, exactly what they did. And then over here, we also have the inflation escalation. This looks very complicated, but it's not as complicated as it appears. All it is, we're just breaking out the rows into columns like this. So of a year and a cost. And then you can just go into your user interface and, tell it what your columns are and what year you want to normalize to or inflate to and what indexes you're intending to use. And with that, I will pass it over to Captain Hogan.
Thanks, Jacob. Let me start sharing my screen here. All right, I should be sharing. So thank you. So I'll be talking about how we perform data transformations in Dataiku. And specifically, I'll show you how I transformed a messy data set of about 78,000 rows and 29 columns to an analysis ready data set of 56 rows and 42 columns without any code in about 3 hours. So really excited to show you this today. If you haven't noticed already, my voice is a little raspy, so please bear with me as I am getting over an upper respiratory infection. So a common estimate is 80% of time is spent collecting and transforming data for analysis. So we can target this step in the data analysis process to save us the most time. And Dataiku makes this step easy by providing a point and click interface with a multitude of data transformations, from combining and splitting data sets, calculating derived variables, interpreting date values, grouping values, deleting duplicates, imputing values, and much more. So these transformations are done in an end-to-end traceable and repeatable flow that will automatically update once new data are provided at the beginning of the flow. So for some background, this data set and analysis was used in my Air Force Institute of Technology Data Analytics capstone project. So I created a cost estimating relationship to predict the unit procurement cost of various fixed wing aircraft programs using a variety of variables such as weight, max speed, max payload, combat radius, and other specification and performance parameters. An Access database called Project Ginger 2 from the Air Force Lifecycle Cost Center was used to generate this initial data set. The original data set consisted of over 78,000 rows and had several missing values, repeated values, and the data were provided at the production lot level rather than at the total program level. Further programs existed in the data set that were irrelevant for the analysis because I was just focusing on fixed wing aircraft programs. So therefore, the data set needed to be significantly transformed for analysis. So for my capstone project, I mainly used Python in a Jupyter Notebook environment to perform these transformations. However, I also performed some queries in Microsoft Access and some prior transformations in Power Query, which really complicates the traceability of the data set and makes for updating the data set unnecessarily complex. Further Python code, there was about 800 lines of code. And because I'm no experienced programmer myself, this took me several weeks to write. And I'm gonna share my screen and go over to the Databricks environment, which is also within Dataiku, or sorry, the Data Vault. So this is a app within the Vault alongside Dataiku that allows you to code in Python and some other languages. And I just wanted to show you, you see the scroll bar at the right there, all of the analysis that went into just preparing these data for analysis. It was a lot of work. It took a lot of time, and obviously you need to be somewhat familiar with Python to carry out this analysis. So let me switch back over to Dataiku. So this is the flow of the preparation, the data preparation for my project. So I'll go into the first cleaning step, which is really the first step in the analysis, and it's largely representative of the original data set. There's a few changes here. So the mission design and mission design series have been masked, and that's really easy to do in Data IQ if you want to mask certain attributes of the data set if you're sharing it. And then I also changed a part of the program name. The first word there is actually the mission design series, and then it's followed by either aircraft production or just production. I changed the first word there to different grape varieties because I need to use this field later and show you some really neat feature of Data IQ. So all the flows are shown on the left, and they can be toggled on and off with a push of a button. So one of the really neat features, that I noticed was Data IQ can automatically parse dates. I know it's difficult to do that in Excel. There's so many different date formats, especially if you look at different 1921s or flex files now. So I'll show you how Data IQ Live can actually parse these data. So we've got a format, the report as of date, and it's so easy to parse this date. You literally click parse date, it will create a new column right next to it, and this column's dates are able to be analyzed using the Data IQ tool. And then I went ahead and removed the other date column just so we're working with one. So that was one really neat feature I saw right off the bat that helps a lot. The other thing I wanted to point out while we're on this cleaning step is that only a sample is shown. So there's 10,000 rows shown here, but the data set was over 78,000 rows. And the other last thing I'll show in this step is there's green bars at the top of each variable. So that represents the amount of data available in that row. And if the green bar does not span the entire width of that row, or that column, I should say, that means there's data missing. So you see there's 18% data empty for the airframe unit weight variable. And so as I mentioned, there's several holes within the data set, and I'll step through how we can fill in some of those holes. So let me step back to the flow. And then I'll go to the next flow. This is just removing the duplicates. So this one's pretty straightforward. With a click of a button, you can remove all the duplicates within the data set. So I went ahead and did that. I'll go to the next cleaning step. So this one's a bit more complex. And it actually groups or aggregates records from production lot data to the total program data. So for example, the data set contain multiple rows of data for each program to provide data for lots 1, 2, 3, etc. But these data needed to be summarized or aggregated for the program as a whole, because I was looking at the program as a whole rather than specific lots within a program. So Data IQ performs this transformation by identifying all the records associated with the higher level group and aggregates these records to the higher level group. So first, I needed to define what the group key is, which is the program name. So I will aggregate everything to the program name at the program level. And next, I need to decide how I want all of the records associated with that program be aggregated. So most of the variables are the same for all the records associated with a program. So I arbitrarily chose the first record here, just because it really doesn't matter. These should be all the same. The ones that matter really are the ones at the bottom that are not marked first. So I wanted to sum the number of units per lot so we can get a total number of units produced for the entire program. I wanted to count the lot number so we can get a number of lots produced. I wanted to get the first or the minimum report date, where that was the first date the program submitted a 1921 report. And then most importantly, for our dependent variable, I wanted to sum the cost for each of the production lots to get a total program cost. And then as you see, I've reset some of the variable names, but Dataiku will automatically append the different variable names with whatever aggregation you chose. So I'll go back to the flow. And then this next cleaning step, I'll show you how I removed all the irrelevant programs from the analysis. And this is another really neat feature within Dataiku. So in this step, I noticed in reviewing the data set that the programs relevant for analysis all have aircraft production in the program names, whereas the irrelevant programs are mainly avionics and electronics programs. So first I will disable the recipe, which I did just then. So this is the entire data set showing now. And then all I want to do is highlight the text within some of the rows that I want to keep. So say I just want to keep all the rows that have aircraft production in the name. And then I'll say keep only rows containing aircraft production. And then Dataiku will give me a preview. It crosses out all of the excluded programs or all of the irrelevant programs and shows the aircraft production programs. So literally a push of a button and you can exclude thousands of rows and really not have to sort through or do some weird filtering within Excel that is hard to replicate. So I'll turn that back on, go back to the flow. All right, so now we want to somehow fill in the missing data that we saw earlier, which I did using median imputation. So median imputation is performed by calculating the median of the known values for each variable and using this calculated median to fill in the missing values for that variable. However, instead of imputing the median across all system types, such as bomber, attack, fighter, transport, tanker, UAV, reconnaissance aircraft, all the different system types within, I wanted to split the data set and use the median of these subsets of data to provide more representative imputations. So I actually created a split recipe, which I'll open here, where I split the data by system type into different data sets. So we've got 4 data sets shown here: fighter, attack, bomber, transport, tanker, and everything else. And the everything else was just a catch-all bucket because there are not enough system types within each of the categories contained in other to have their own category. And then this recipe will actually output 4 different data sets. So let me back up to the flow. So we see 4 different data sets here. And then I'm going to go in and show you how we imputed the data within the fighter and attack aircraft data set here. So first, before even imputing any data, I really wanted to look at the distributions of the data set. So one really easy way to do that is either, and I'll go over to the first empty row that I disabled here. You can either go to Analyze and see some great statistics on the program, not only a histogram, box and whisker plot. You can look at these by categorical variables. We see that 8 records do not have a value and are missing. The other thing, if you don't want to go through and look at each variable one by one, you can do a quick view. So it'll pull up a window at the right where you can see the distributions of all the variables. And you see all of these are green because I've already imputed the values on these, but I'll give an example for the one that I disabled. So to impute a value, again, very easy. Go in here, go to more actions, fill empty rows with, median, okay, and it'll fill in the missing values with the median, which was 16,406. So go back out my disable step and then go back to the flow. And then, so after I did that for each of the 4 data sets, I've imputed data for all 4 data sets. I go ahead and combine those data sets. Again, this is pretty easy to do in Dataiku. So none of the columns change. The schema, the underlying schema of the data set did not change. So very easy for Dataiku to identify, how to merge the data set again. And then it outputs a single data set. And then I do a few more data cleaning steps that I won't get into. Mainly, in those steps, I change the dependent variable from total program procurement cost to program unit cost. So we'll look at some of the results in the end. So as you see, the data set is now 56 rows, 42 columns, because I did some additional transformations on changing the independent variables to a natural log, and then also changed the dependent variable to natural log. All the data are now aggregated at the program level. They do not contain any holes, no holes in the data set, and there's no duplicates, and only the relevant data are shown. So the fixed wing aircraft program data. So the last thing before going to do any analysis on this is it's always good to visualize your data. So I went ahead and created a quick scatter plot where I graphed the natural log of the program unit cost in constant price dollars. On the y-axis, one of the most influential independent variables, which was the natural log of empty weight, on the x-axis, and then graphed it by system type. So I can even show you very quickly how I created this scatter plot from scratch. So scatter plot, system type, the empty weight is our independent variable, and then our dependent variable is unit cost. So now that we've done all the imputation, excluded irrelevant data, filled in any holes, the data is really ready for analysis. So that's all I've got to show you today. Happy to take any questions. Thank you.
Thanks so much, Captain Hogan. I have been monitoring some questions here in the chat, so I'll at least start off. And I know that you guys don't have the capability to come off mute. So if you have any other additional questions, feel free to jump back in the chat, and then we'll do our best to get to everything. So let me share screens a bit. So we had a couple of really good questions. I'm going to start with someone asked, is this an enterprise version of Dataiku? Hopefully, let's see your screen sharing. Yeah. Okay. Yes. So one of the things, and I'm really glad you asked that, because we had not really mentioned this yet. But one of our favorite things about this tool is just your ability to collaborate with others as well. So when you let's say create a project, right, by default you are the only person with access to that project. If you decide that you want to collaborate here, so let me just show you, go into this one for this model. But if I want to, for example, for security for my project, I can start to add different personnel. You have access not just for the people within your tenant space, but actually anyone that's in a vault that has a Dataiku license is here. So at that point, you take ownership and responsibility for managing the control of your data, just like you would if you're emailing someone or placing something on a shared drive, right? So the same sort of idea. What's really powerful about this as well, though, is the enterprise version. If I want to share this with the whole group, I can do that. But I can also manage individual permissions. So here, if I want someone, for example, to have access to only a selected portions, where I only want them to be able to, for example, read my dashboards. I don't want them to be able to do anything else. I can do that as well. So once I start to click around, if you just want them to read your dashboards, you don't want them to have access to your flow, any of that raw data, see anything, run anything, all of that's possible as well. And then you can collaborate. So real time, you can be in the flow with other users. And then you can actually see, I can go here, version control, and this one's not going to be very fun because it's all me. But if different users are in, you can actually, like I said, go back and you can revert to even any other previous version of the model. So if someone goes in, or even you go in and accidentally break something, it's you just revert back. It's not a problem. So very collaborative, and like I said, real time. You can actually see who's in the project doing what. Let's see. I had another great question from Dave about just doing checks. So yeah, and he was asked, I think the specific question was, hey, if you have a data set, so let's say you have specific errors, like if all the data points on a program have the same weight, or some sort of error checking, that types of things. Absolutely, there's several things you can do. There's a couple different ways to do it. I'm just going to give here, let me make sure I'm in my demo version here. So for example, if you go into the data set, we didn't talk a lot about it, but just the same way you can and you can do a prepare step to add a formula. You can basically think about it as a calculated field. So here, let me go into this one. So if I want to, I can do this where I can, add a calculated field here where there is a formula function. Add this. So pretty much any formula you want, right? Just kind of the same way as you would do in Excel. There's also some other options that are a little bit more technical that I won't go into here, but you can actually run within your project different scenarios as well. So you can have different triggers for either the inputs or outputs or data sets. You can actually run those scenarios, create those scenarios. I started to kind of do this here, so I could show you, but you can add steps within that scenario, things that you want to do. Et cetera. So there's a couple different ways to do that. Kind of depends on what you're checking and how you want to do that. So great question. Let's see. And I could probably find metadata. Yeah, I mean, as we go, honestly, our biggest issue is always getting consistent, clean, especially, any sort of normalized, standardized data. So there are tons and tons of options here. I do want to make, Adam James made a comment earlier. It's not just if you're trying to do data science, right? If you are trying to build any kind of cost estimate and you're doing any kind of data analysis, this will help you automate your processes from beginning to end. So you might have seen some of the things that Captain Hogan was showing, and you might think, well, I can do a lot of those in Excel. And while that is true, think about it this way, once you introduce new data, for a lot of those steps, you have to go back and do it all over again, right? So one of the key things that he said that I just want to emphasize is one of the biggest, I would say, pros and about using this tool and or any other automation, right? If you're using Python, any other automation you want to use, one of the biggest pros is once I get this new data, that's my raw data, right? And the idea is that you bring that in, the raw data as much as possible, from the original data source, and then you build all the steps from there, so that literally I can just run. So for example, if I added new data, I can go, and I'm just going to show you guys this really quick. I can, either I can do a smart reconstruction where it actually goes and it only rebuilds what it needs to. It will recognize that I have new data, and it will rebuild anything that it needs to rebuild because of that new data. So again, it'll take like a minute to 1 minute instead of going back and repeating all those steps over again. It will rerun all that. Now, whenever you introduce new data, obviously the same way you would, I think Dan said something. Dan, sorry, I won't quote you here, but I'll give you credit at least. It's automated processes, not automated analysis. So we're not trying to automate. We're not trying to pull in the data, kick out the results. The analyst is removed from the situation. It's actually the opposite. This will enable our analysts to be even more involved, right? So instead of spending a bunch of time in Excel trying to do things manually, you can do that much more quickly. And then you can really spend your time in the prediction and modeling and deep dive into some of those, some of the, more classical modeling. Even if you're not doing this, this will help you, even if you're not touching machine learning with a 10-foot pole, even if you only have, maybe smaller data sets, or even like Captain Hogan was showing, just data transformation, things like that. So I don't want to give the impression this is some sort of, only when in the data science realm or only if you have 1 million data points. That, it's definitely not true. So I also appreciate that comment. And I think we're almost out of time. I know we have, sorry, actually, I forgot we had some other charts. So I'm going to put up the ICEAA charts. I really appreciate it. Feel free to send me an email, anything like that if you have additional questions. So.
Thanks, Sarah. Yeah, we'll go ahead and go through these. So there's a survey, a lunch survey that would like people to fill out. We can post that into the chat here. And then the results of this would be used to help determine the winner of the Luncheon Speaker Presentation Excellence Award. And we also, in any future presentations, we can get your feedback as well and try to get some of the presentations to meet those needs as well. I'll grab that. Right. If we go to the next slide. So we're encouraging people to become ICEAA members if you're not already. Each year we have ICEAA has a professional development and training workshop. It's people get together in a different city. There's multiple presentations. This presentation was also featured as well this year in Pittsburgh, which we had just last month. And there's local and regional seminars. You get discounts to attend the professional development and training workshop. Also get access to training materials if you want to get your certification as a PCEA or a CCEA and take the certification exam. That discounted pricing on the CBOC training, as well as subscription to ICEAA World and other publications where you can submit articles as well and be part of the community. You go to the next slide. So our membership fees are $95 for 1 year and then $170 for 2 years. You get a little savings if you do multiple years, but certainly can do it on a year-by-year basis. And check with your company or organization; they may reimburse your membership fees. A lot of the companies do that as well. So we'd love for you to be part of this community and be really engaged. And I'm going to hand it over to Dan Germany here for upcoming events.
Thanks, George. And hey, thanks everybody from the AFCAA team for that presentation. Love seeing the sort of future tools that we have out there that can help optimize our workflows. And so thank you all for the time today. Moving forward. Oh, sorry, Sarah. Can you go back there real quick? Moving forward, just want to let everybody know next month's luncheon event will be, we'll have Lieutenant Colonel Dan Summers from OSD Cape, a coworker of mine, introducing CAPE's latest update to the Analysis of Alternatives Handbook. So if you have to do some analysis of alternatives coming up soon, or if you wanted to learn what those are like, definitely join us next month to get a sense of that resource and learn a little bit about AOAs. We are actively looking for folks, organizations or groups that can help host in-person networking events. We've got one scheduled, or we're scheduling one next month at Quebec. But if you have a great facility that you want to help show off and you want to have some do some networking and some socialization in person rather than just virtually like we're doing here today, definitely reach out to us at that email address at the bottom of the screen. And also, if you've got a topic that you want to brief on during one of these luncheons, we're always looking for folks that want to show off some cool stuff or talk about what they're doing. So by all means, drop us a line, and we hope to see you again next month, both in our luncheon and hopefully in person at Quebec. Thanks, everybody.